Hey, now we studied the Pythagorean theorem, and we're still in this right triangle trigonometry unit, so you figure we're going to keep playing with right triangles. Hey, it looks like the whole game's showing up. This is going to be so exciting. There are two, not one, but two right triangles that are referred to as the special right triangles that we just want to be able to memorize. Okay, now the easier of the two is the 45, 45, 90. Of course, one of the angles has to be 90 degrees, otherwise it's not a right triangle. And that leaves 90 degrees left over. Well, if we make them so we have an isosceles right triangle, those two acute angles are congruent, right? They have equal measure. And since the acute angles are congruent, the legs have to be congruent. So I decided just to make them one. And the hypotenuse is always root 2 times a leg. Right? If you want to check that with the Pythagorean theorem, a squared plus b squared equals c squared, you can pause the video and you can do that. I'm quite convinced, though, that you will find that if each leg is 1, the hypotenuse has to be square root of 2. In the memory aid that I use, 2 equal sides, use root 2, right? Think the 2 and the 2. 2 equal sides, use root 2. Or you can think of it as being 2 equal angles, use root 2. Now, does this root 2 trick really work on a different triangle? Because I just told you it's going to work. So let's get a different triangle and see if this actually works. Okay, so again, it's got to be a 45, 45, 90 triangle. I'll put a 6 for one of the legs. Now, of course, if one of the legs is 6, the other leg also must be 6 because those 45-degree angles are equal to each other in measurement. And now I want to go find the hypotenuse. Okay. Of course, I claimed on the previous slide that it better be 6 root 2, but let's see if it really is 6 root 2. What am I going to write down first? A squared plus b squared equals c squared. And of course, a and b are going to be 6 and 6, right? Because those are the legs. So 6 squared plus 6 squared equals the hypotenuse squared. Of course, 6 squared is 36. The other 6 squared is also 36. Add those together, I get 72. Square root of 72. I want to see, 8 times 9, 24 times 3, 36 times 2. 36 is the largest perfect square that is a factor of 72. I almost did 9 times 8 because I can take the square root of 9, but then I'd have to simplify the square root of 8. This is like my one-stop shopping here. If I do 36 times 2, I can do this in just one step. Square root of 36 is 6. Oh my goodness, how about that? If the leg is 6, the hypotenuse really is 6 root 2. Now, does it work on any 45, 45, 90 triangle though? For any leg length? Well, what am I going to use for any leg? If I want to give one of the legs a measurement, what's it going to be? Well, mystery number x. Right? If I want it to be anything, I better call it x. And of course, if one of the legs is x, the other one also has to be x. So what's the hypotenuse? Well, you know I'm going to start with a squared plus b squared equals c squared. A and b are each x. X squared plus x squared, that's 2 of them, right? That's 2 of those x squareds. I got to take the square root. which means I got to take the square root of the 2, and I also take the square root of that x squared. Notice I put the square root of the x squared first, right? With multiplication, I can change the order, and it still works out just perfectly fine. Square root of x squared is just going to be x. Holy cow! For any leg, if I know the length of the leg, I can multiply it by root 2, and I've got the hypotenuse. Can you believe that? That is awesome. So this is one of the special triangles that we want to memorize. Keep it in your memory bank. Now, the other special right triangle, not quite so easy to remember, is the 30, 60, 90. So the smaller of the acute angles is 30 degrees. The larger of the acute angles is 60 degrees. And then, of course, we've got the right angle. Notice the smallest side, which happens to be 1, is opposite the smallest angle, 30 degrees. Now, the middle size angle, right, 60 degrees, you're like, well, what is square root of 3? If you grab a calculator, square root of 3 is pretty close to 1.7. And so that's kind of like the middle side, right? 1.7 is more than 1, but 1.7 is less than 2. So the second longest side is across from the second largest angle. And then, of course, the largest side, the hypotenuse, is 2, which is across from the largest angle, which is 90 degrees. So, the shortest side, right, the shorter of the two legs, must be opposite the smallest angle, 30 degrees. The side opposite 60 degrees, the longer leg, is always square root of 3 times the shorter leg. So if I know the shorter leg, I can multiply it by square root of 3, and I get the longer leg. Hypotenuse, of course, has to be across from the right angle. Longest side of the triangle. Notice it is 2 times the shorter leg. So if I know the shorter leg, which is the shortest side on that entire triangle, I can multiply it by 2, and I've got the hypotenuse. Memory aid that I use, 3 different sides, use root 3. Right, when 2 sides were the same, I used root 2. That was on the 45, 45, 90 triangle. Right, because the 45 and the 45 match, so I had 2 that were the same. This triangle, there are 3 different sides, so I use root 3. Just got to remember that the largest number involved is the 2, because square root of 3 is only about 1.7. Now, can we prove that this relationship must be true for any length? Right, instead of doing a triangle where I just start picking numbers, I'm going to actually just say, no, let's go about it, because unlike the 45, 45, 90, I don't have 2 sides that are equal in length. So if I decided to name one of the sides with a number, how could I possibly figure out what one of the other sides was unless I was using this trick? But that doesn't prove that the trick works. It just says, hey, look, I used the trick. So we're going to start with the equilateral triangle. Equilateral also means equal angular. So if all 3 sides are equal in length, all 3 angles have to have the equal measurement. And so if one of the sides has a length of 2x, every single side has to have a length of 2x. If you're wondering, why did I pick 2x instead of just plain old x? Hang on for a second. Now, let's construct an altitude. I can't even speak right. Construct an altitude, also known as the perpendicular bisector. Right, we worked with these in geometry. If we bisect one side and make it perpendicular at that midpoint, we have the altitude of the triangle. And of course, on this one, that perpendicular bisector also bisects that angle. So notice that the angle that was at the top of the triangle has been bisected. So instead of 60 degrees, it is just 30 degrees. Oh my goodness, and look at the side that's on the base of that triangle. It's been cut in half. So instead of 2x, it's just x. So sure enough, on a 30, 60, 90 triangle, the hypotenuse must be exactly 2 times the length of the leg that's across from the 30-degree angle, right? And so that's why I started by picking each side to be 2x, because I knew I wanted the hypotenuse to be 2 times the short leg, so I wanted the short leg to be x. What's that mystery side? Well, we know it's supposed to be x times the square root of 3, but we got to demonstrate that, right? And so to demonstrate that, how are we going to find the longer leg? A squared plus b squared equals c squared. I mean, what else am I going to use? It's right triangle trigonometry. Right triangle means I can use the Pythagorean theorem. I know one of the legs is x. I decided to put that in for b. I could have done either a or b. I know the hypotenuse is 2x. That must go in for c, right? Hypotenuse is c. 2x quantity squared, well, let me see, 2x times 2x, 2 times 2 is 4, x times x is x squared. I gotta get a squared all by itself. Let's subtract x squared from each side. 4x squared subtract 1x squared leaves me with 3x squared. Now, if I want a, I better take the square root. Square root of x squared, of course, is going to become x. Square root of 3, of course, I'm going to be stuck with. And sure enough, the longer leg is the short leg times square root of 3. Now again, basic reminders, angles are capital letters, sides, lowercase letters. Sides have to be opposite the corresponding angles. And I will always use C for the right angle. Now, for some of us that are visual learners, you might need to like draw the triangle for each one of these. So if you need to pause the video and draw some triangles, goodness gracious, pause the video, draw some triangles. But I want to go through and complete this table. So that first column with the 1 in a circle on top, that's saying, hey, this is like triangle number 1. I know angle A is 30 degrees. I have no clue what angle B is. Angle C is 90 degrees. Side A is 5. I don't know side B. I don't know side C, which happens to be the hypotenuse. Well, let's start filling out this table. So on this first triangle, hey, I put 60 degrees in there for angle B. Now, how do I know it's 60 degrees? They've got to add up to 180, right? If I've got 3 angles in a triangle, those 3 angles have to add up to 180 degrees. Hey, where did that 5 root 3 come from? Well, if I know the short leg on a right triangle, I know that the longer leg is going to be the short leg times square root of 3. What's the hypotenuse? Well, if the shortest side is 5, I have to double it, so the hypotenuse will be 10. Again, if you want to try number 2 on your own, pause the video and then turn the video back on when you're ready. What's the missing angle? What could angle B have a value of? Well, they got to add up to 180, so it's going to have to be 45. So it's a 45, 45, 90 triangle. How about side B? Well, since angle A and angle B are equal in measurement, side A and side B have to be equal in measurement. How do I find the hypotenuse on a 45, 90? I take a leg and I multiply it by √2. There's the length of the hypotenuse. Notice I'm not using a calculator. I'm not putting in some crazy decimals. These are exact answers. Okay, triangle number 3. What's the missing angle? Well, it must be 30, right? 30, 60, 90. That adds up to 180. Uh-oh, I don't know the short leg. I just have the hypotenuse. Well, if I had the short leg, I would multiply by 2 to get the hypotenuse. So to go the opposite direction, if I have the hypotenuse, I will divide by 2. 8 divided by 2, 4. Now, of course, if I know the short leg is 4, and I want the long leg, I multiply by √3, 4 √3. Again, pause the video if you want to try to do number 4 before I explain it. Number 4, angle B. Well, it's going to have to be 45 degrees, right? Because they got to add up to 180. Uh-oh, I know the hypotenuse. I know the hypotenuse has to be √2 times one of the legs. So to go backward, if I know the hypotenuse, I have to divide by √2. All right? So to figure out the length of side A, I know that I should take side A, multiply it by √2 to get the hypotenuse. And so if I want to figure out side A, it's going to be the hypotenuse divided by the square root of 2. And of course, I know the hypotenuse is 6. Okay, so now we got to brush off some of our algebra skills that hopefully date back quite some time. How do I do 6 divided by square root of 2? Come on, we're not going to do that. I'm going to multiply by the number 1, right? I can always multiply by the number 1 and not change the value of an expression, right? 6 over square root of 2 times 1 is still 6 over square root of 2. But this is kind of like where Peter Parker goes into the Bat Cave and comes out as Superman. I think I got those superheroes all correct there. The number 1 is in disguise √2 over √2, right? That's really the number 1. And how does that help us? Well, look at the bottom of the fraction. Square root of 2 times square root of 2, that just becomes plain old 2. Right? I can either think of it as becoming square root of 4, which is 2, or I can think of it as square root of 2 squared, where the square root and square cancel each other. Okay, so now I have, wait a minute here, 6 divided by 2? Right? That 6 is really 2 times 3. Cancel the 2 from the numerator with the 2 on the denominator. I'm left with 3 √2. That is the exact value of that leg, 3 times the square root of 2. Now, the legs have to be equal to each other in length because those two angles were equal to each other in measurement. And so the other leg has to be 3 √2. Okay, triangle number 5. What is shaking with this bacon, huh? Well, it looks like the missing angle is going to have to be 60 degrees, right? It's going to be a 30, 60, 90. I know the longer leg is 12, so the shorter leg. Normally, I would take the short leg and multiply by square root of 3 to get the longer leg. So if I want the shorter leg, I'm going to have to take the longer leg and divide by the square root of 3. Of course, I know the longer leg is 12. So I need 12 divided by square root of 3. Again, I can multiply by the number 1. So Superman can fly back into the Bat Cave and come out as Peter Parker. Right? The number 1 is secretly square root of 3 over square root of 3. And of course the denominator, square root of 3 times square root of 3. After a little bit of repetition there, comes out as plain old 3. I don't know why I had that extra one on there, but we'll just pretend it's in its place. 12, of course, is 3 times 4. The 3's cancel. I get 4 root 3. Whew, that was a long one. Oh boy, now I gotta find the hypotenuse. Oh, piece of cake. I just multiplied the shorter leg by 2. Right? 4 root 3 times 2 gets me 8 root 3. Piece of cake. Oh boy. What is this last triangle? 60 degrees is one angle. Do I really know it's a 30, 60, 90? Yes, I do, because side C was twice as big as side A. So if I knew that one of the angles was 60 degrees, and notice it's not the angle across from the 2, it's not the angle across from the 4, that's actually enough of a clue that I can deduce that's a 30, 60, 90. If you remember from geometry when we were doing proofs, if you knew 3 parts of a triangle, you can usually find the other 3 parts of the triangle. Right? There are a couple of bizarre exceptions where if you just didn't have the right 3 pieces, it wouldn't work. But in most cases, right, if I know 3 pieces of a triangle, I can find the other 3. Right? And if we knew 2 sides and we knew the included angle, side, angle, side, that was one of our valid proofs. And that's what we had here, right? We had side, angle, side, where we had side A, angle B, and then side C. And of course, the longer leg has to be the longer leg has to be square root of 3 times the shorter leg, or in this case, 2 times the square root of 3. Oh, let's get to that worksheet. Come on, go through the maze. Come on, smiley face. That smiley face is going to try to get to that worksheet. And of course, we have an IXL. This time it'll be Y2. And Y2 is going to be special right triangles. And again, our class is Algebra 2. Some of you, when you log on to IXL, you'll actually see the Algebra 2 tab. If you can't find the Algebra 2 tab, you're looking for level M. And for this assignment, I'm going to run another special. And I'll say, hey, your goal is to come up with a score of 40. So the goal today is 40, right? You don't have to get all the way up to 80, right? And again, what's going to happen with the IXL is that they're going to give you a picture or a description of a triangle, and it's going to either be like a 30, 60, 90 triangle, or it's going to be a 45, 45, 90 triangle. And they're going to say, hey, if one of these sides has this length, what's the length of the other one? And it's almost really easy if they give you like the short leg on a right triangle, or if they give you the leg of a 45, 45, 90. But when they give you a 30, 60, 90, if they start you with the hypotenuse and they want the longer leg, or if they start with the longer leg and they want the hypotenuse, It becomes a multi-step question, and so you'll quickly discover today that for IXL, by the time you hit 40, you'll say, I've had enough of this for one day. All right. So the goal today on IXL is 40. We've got the worksheet, and other than that, we should be good to head on out and do some mathematics.